Hello, my name is Daniel Rich, and this presentation will walk through the development of a use case in order to verify and validate the analysis models that represent it. The scenario we will examine is Perfect Pizza's business processes, and the use case in question will be called the take order use case. The purpose of a walkthrough is to consider the models and diagrams created during analysis using a peer review procedure. Analysis is an iterative process, so as we go through the presentation, make note of any faults or inconsistencies in the models. Consider questions about the representations, look for omissions or repeated information, and try to identify anything that could be confusing. In this early phase of development, the use case will be an overview. The identified requirements of this business process come from the scenario described. For this pizza delivery business, a system is needed to record customer orders. The following use cases can be established from the scenario: an incoming phone call, phone number pulls up customer information, input information if necessary, the order is taken, the total is calculated, order is given to the cook, the receipt is printed, coupons are printed if they are available, delivery drivers provide receipt and coupons, and the weekly summary reports are created. The use case we are developing is the take order use case. Based on the requirements of the business process, an activity diagram was created. The activity diagram will provide a framework for fleshing out the take order use case. For visibility, the activity diagram has been split into two parts. From the initial node, the first action has been designated customer phone call. This action leads to a decision node. If the guard condition new customer exists, the input customer information activity will be executed. Otherwise, the control flow will pass on to the merge node with no activity. The next activity is take order, followed by calculate total, then get payment information. The flow leads to another decision node at this point. If the guard condition cash is met, the cash payment action is executed. If the guard condition credit card is met, the credit card payment action is executed. If the guard condition check is met, the check payment action is executed. All three actions lead to a merge node, followed by the print receipt action. Another decision node comes next. If the guard condition coupon available exists, the print coupon action is taken. If there are no coupons, no action is executed, and the control flow moves on to the merge node. The next action is give order to cook, followed by the add total to weekly summary activity. The final activity is delivery, and the control flow stops at the final activity node. The activity diagram was reviewed and used as a starting point to create a use case description. The subject of our walkthrough, the take order use case, was expanded and refined for the use case description. Like the activity diagram, this use case description has been split to increase readability. The use case name is take order, and the ID number is 3, reflecting its position on the activity diagram. This use case has been given a high importance level. The primary actor is clerk. The use case type is overview essential. The stakeholders identified are the customer, who wants to place an order, and the owner of the business, who wants to make sure that customers are satisfied. As a brief description, this use case will describe how a customer's order is taken by a clerk. The trigger is the customer call and wants to place an order for pizza or wings, and this is an external trigger. For relationships, the association relationship is the clerk, the include relationship is a get payment information. Two extend relationships exist, the input customer information activity and the print coupon action. And there were no generalization relationships identified. For the normal flow of events, the clerk answers the incoming phone call, the clerk then obtains customer's information, the clerk confirms existing customer information in the computer, the customer gives the order to the clerk verifies order information with the customer, the clerk calculates total order for the customer, the clerk asks if payment will be cash, check, or credit card, which will lead to subflows. For subflow 1, the cash payment subflow is implemented. For subflow 2, the check payment subflow is implemented, and for subflow 3, the credit card payment subflow is implemented. Next, the clerk prints the receipt, and finally the clerk gives the order to the cook. For the subflows, subflow 1 cash payment, the customer indicates they will pay with cash. Subflow 2 check payment, customer indicates they will pay with check, and the clerk tells the customer to include their driver's license number on the check. For subflow 3, the credit card payment, the customer indicates they will pay with a credit card, the clerk obtains the credit card number, and the clerk processes the credit card payment. Alternate or exceptional flows that were identified: for 3A, the clerk executes the input customer information use case. 7A, the clerk executes the print coupon use case. A use case diagram was created to illustrate not only the main functions of this system, but also the different kinds of users that will interact with it. The use case diagram will provide an opportunity to identify additional requirements and also remove some actions that are not essential or minor enough to merge with a related activity. The first step was to set a boundary. Next, the use cases were added along with their relationships. Then the actors were identified and included. The specialized actor new customer inherits the behavior of the customer actor and extends it. The associations were added between the actors and use cases with which they interact. And the last step was to review. It was decided too many use cases were included, so a few that were less essential to the take order activity were merged. For the purposes of verification and validation of the take order use case, do the analysis models represent the problem domain faithfully? Before moving on to more specific tests, consider the following criteria for potential modification and improvement of the models presented. Errors. Were any elements labeled incorrectly or placed in the wrong sequence? Fidelity. Do the models all describe the same functionality in a consistent manner? Completeness. Were any necessary actions, use cases, or associations not included? Redundancy. Did any of the models contain non-essential or repeated elements? Clarity. Was anything about the models vague or difficult to understand? This concludes the walkthrough of the take order use case. Hopefully this peer review of the analysis models has improved understanding of the take order system and will enhance the functionality of the design model that will be derived from it.